Hello guys, you are welcome to the GMAT 41's physics class. In this class, we shall continue from our previous class where I derived the progressive wave equation. So what we're going to do right away is to see how we can apply that progressive wave equation to solve wave problems. Here on the board, I've got this question. A wave is given by y equal to x of t. This simply means y depends on x and t. This x is distance and t is time. And that is giving us this equation here. 200 millimeter sine open bracket 5.0x minus 20.0 t. Where x is in meters and t is in seconds. So we are required to find what the amplitude of the wave is. Number 2, find the wavelength, frequency, and period of the wave. Then, of course, we are to find the wave number, the angular frequency of the wave. Wave number and angular frequency. So, in solving this problem, we would have to rely on the progressive wave equation. Are you following, right? I believe that we've learned that. We're going to see how we apply it to solving this question. So here we have the progressive wave equation given. All we have to do is to compare it with the one that has been established already as the standard equation of the progressive wave. And then we shall now pick certain necessary terms. Okay, so come along as I solve this. This equation has been given to us. Y equal to 200 millimeter sine 5x minus 20t. So like I said, we are going to compare this equation with the progressive wave equation, which we know. Now if you look at it, you have a number here times x, you have another number here times t. So we can think of the particular form of progressive wave equation that is closely related to this one that the question is based on. Now I'd like you to recall y is equal to a sine open bracket kx minus w, that is omega t. I believe that you remember this progressive wave equation. If you compare this and this, you will agree with me that you have y to y, they take care of each other. Then a, the amplitude, to 200 millimeter. Just after the amplitude you have sine. Look at it. It therefore means that this A amplitude is equal to this value, 200 millimeter. So I'm going to bring that out. If you do the comparison, A is equal to 200 mm. And of course, we shall convert this to meter. So it means that the amplitude is equal to 200 times 10 to the power of minus 3. If you are converting millimeter to meter, you multiply that millimeter value by 10 to the power of minus 3, which is the same as dividing that millimeter value by 1000. Are you getting me right? Solving this out, we shall get that the amplitude is 0.2 meter. That's good. Let's continue in our comparison. This is sine. Yeah, they take care of each other. Then you approach the bracket. You notice you have kx. And that would definitely be equal to 5.0x. Why? Whenever you are doing this comparison, please, dear friends, you want to be particular about x and t. X and t are the two variables, okay, that helps us to compare the part of what we call the wave number from our previous class and what we call the angular frequency. The wave number in this case is k. The angular frequency is what? W. So you are going to look at, okay, I have x here. I have x here. Automatically, whatever that is multiplying x in this equation will be equal to what is multiplying x in the given equation in our question. Therefore, we could say that our k is equal to 5, all right, 0.0. This k is your wave number. The k is your wave number. 5.0 or simply 5. Are you getting me right? Or simply 5. And we stated that the wave number has the unit radian per meter, that is rad per meter. You want to take note of that. So again, if you move on, you notice that your T term, look at it. What is multiplying it here is W, omega, angular frequency, angular velocity. Please, dear friends, whenever you are doing this comparison, don't bother yourself with this minus. The minus is a follow-on minus. Although in my previous video lesson, I didn't talk much about that concept. See, that minus, it came from the formula. It's follow-on. It doesn't belong to this X part. It doesn't belong to this T part. You know, why I'm saying this thing is because your examiner can still decide to rewrite this equation in such a way that 20t will come first, then minus 5x. Are you getting? The t part can come first, followed by what? The x part. Let me just show you here. Let me write it down. This is what I mean. The equation can be given as y equal to a sine open bracket wt minus kx. You see? So this minus is the follow-on minus. When you are doing this analysis, just be interested in the quantity only. Is that clear? And do your comparison. So we move on. In the t part, you notice that I have angular frequency multiplying t. In the given question, you have 20 multiplying t. Automatically, it tells us that angular frequency is equal to 20 or simply 20.0 or 20. 20.0 is the same as 20. And the unit of angular frequency is rad per second. Rad per what? Per second. It's just like meter per second when dealing with our linear motion concept of velocity. So I have done one of the most important things whenever a problem on progressive wave equation is given to you, the comparison, being able to bring out the data, very important. So with this information, we shall now proceed to answer the given question. The first one we've answered it already. What is the amplitude of the wave? The amplitude of the wave is 0.2 meter, just straight on the no given formula, the coefficient of that sign. And then find the wavelength, the frequency, and the period of the wave. So let me take this as the first part of the question. This is the first part of the question. Now the second part, we are asked to find the wavelength. We don't know. We are asked to find the frequency. We don't know. We are asked to find the period, capital T. We don't know. So we shall apply their formulas, okay, and see how we solve that. You know that to get your wavelength, there is this equation, all right, under progressive wave equation, that tells us that wavelength is obtained from the x part. From the x part. See this k. The k called wave number is equal to, k is equal to 2 pi divided by the wavelength. So from here we can calculate our what? Wavelength. So the implication is that wavelength is equal to 2 pi divided by what? K. Wavelength is equal to 2 pi divided by k. So let us substitute and see. Let's substitute and see. The implication is that the wavelength is equal to 2 pi divided by the wave number k is 5. So if we divide this, we could have our answer like this if we want in meter. Okay? But you can still choose to, or you can choose to substitute the value of pi there, which is either you use 22.7 for pi or you use 3.142 for pi. Anytime pi is standing off a trig function, that is to say half pi, and that pi is not in front of sine, it's not in front of cos, it's not in front of tan, the pi is taken as 22/7 or 3.142. But let us assume that this formula is something that maybe this pi appears in front of a trig function like sine, cos, or tan. Let us assume it is lambda, that is wavelength, equal to sine 2 pi over maybe 5. In that case, because that pi appears in front of a trig function, it could be sine, it could be cos, it could be tan, like I said. The value of that pi is no longer 22/7. It's no longer 3.142. Rather, it will be taken as an angle in radian, 180 degrees. Okay? So always remember this. You can jot it down somewhere in your notes so that you don't forget. Now with this, I'm going to evaluate wavelength to be equal to 2 times 3.142 divided by 5. So let us reach out for a calculator and evaluate that. Working on this, this gave me 1.26 approximately in meter. Okay? 2 times 3.142 divided by 5. So I got 1.26 approximately in meter. So we are done obtaining the wavelength. And that is how simple it is. We now have to move on to obtain the frequency. And how do we get our frequency? Once again, from the wave equation given, the frequency is obtained from the time part, the t part, where you have the angular frequency. Look at it. This part, that is where our frequency is obtained from. Now you recall this formula that omega, that is angular frequency, is equal to 2 pi f. So from here, the implication is that frequency will be equal to angular velocity divided by what? 2 pi. And then we can do the substitution. The implication is that the frequency is equal to angular velocity from the question, look at it, is 20. And so we're dividing this by 2 pi. If you work this out, you're going to get 10 over pi. The unit of frequency is hertz or per second. Hertz or per second. So that could be our answer. Or you may choose to substitute the value of pi there, so that frequency will now be equal to 10 divided by 3.142. Let's reach out for a calculator and obtain the value. Okay, so this is 10 divided by 3.142. So I got 3.18. 3.18 as the frequency, hertz. Good. So you see, solving this problem is simple. There is nothing difficult in it. Once you followed up with our previous class where I derived the progressive wave equation formula, you play around with this. Now we shall move on to get our period. But that's simple. Period is 1 over frequency. Okay, so why not just solve that and see? Period is 1 over what? Frequency. We have the frequency value already. Either you use this or you use this, depending on how your examiner wants it. If maybe it's a CBT exam where you have options provided, if the options are given in terms of pi, then this would be your answer. But if you don't have any pi in the options, it means they substituted the value of pi and then simplified. So you get this as your answer. That's why I have my or there, or this. Okay, so let's just work out the period straight on, no time. We have finished this question, even the third part. The third part, we have gotten it, and I'm going to tell you how come. But let's get to our period quickly. Period is 1 over frequency. So simply do 1 over 10 over pi. If you do that, you're going to get pi over 10. You can watch that on the screen as it appears, okay? So period is equal to 1 over f, and then simplifying further, fix the f, 10 over pi, and then that's going to simplify to give us period, capital T, to be equal to pi over 10. And the unit of period is second. The unit of period is second. Suppose the option does not bear pi. Let us assume that the value of pi was substituted. Of course, the period will go further to give you that pi, you fix 3.142 and then divide by what? 10. So let's reach out for a calculator and see. 3.142 divided by 10. Good. This gives 0.31, approximately 0.31 second. So the period is either pi divided by 10 seconds or 0.31 second, approximately. I hope you understand that, right? Okay, now let us look at the last part of the question, because I'm not going to solve anything on it. We already got their values. What is the wave number and angular frequency of the wave? Directly from the given equation, from the given progressive wave equation, we can get our wave number and the angular frequency. Wave number k is the number multiplying x, which of course we obtain from here to be what? 5.0, or simply 5 radian per meter. Okay, so we have gotten the answer of that. If you still want to punish yourself after getting your wavelength lambda to be 1.26, you can substitute it back here to calculate k. You still get your 5 approximately as your wave number. Then talking about angular frequency, omega, angular velocity. That is the coefficient of t. What is multiplying t in the given equation? And if you come over here, we already extracted it. Look at it, it's 20. If you do the comparison, so our angular frequency as requested in the third part of the question is 20.0, or simply 20 radian per second. And that is how we deal with this question. I hope you enjoyed it. If you have any question, please feel free to make use of the comment box. In order to prioritize your question to get more benefits, so that your question can be given a quick response to, you can become a channel member, okay? Because once you do that, you get more exclusive benefit. As you ask a question, immediately it appears, okay? I'll get the information and then I'll respond to it. But in any case, you can still make use of the comment box, like I said. Please like and share these video lessons to other scholars so that they can benefit from it. If you are yet to subscribe, please kindly do so, okay? I hope to see you in my next video lesson where we'll be treating one aspect of wave property. We'll be talking about the concept of reflection. I would give much more attention to the application of reflection with respect to the pinhole camera, where we're going to deal with the magnification of this guy. And then we'll also look at the application, talking about reflection of light wave on plane surface. We're going to study the case of plane mirror and then determine the number of images that an inclined mirror to another one. That's the number of images that maybe two mirrors that are inclined at a certain angle can form. You will not want to miss out in that class, so make sure you follow up. If you have not personalized the subscription, please do so. Tap that bell icon close to the subscription button after you subscribe. Then personalize the subscription so that once I upload a content, any new one, you'll be personally notified. Please, friends, do have a wonderful time. And always remember, from GMAT 41, take your studies seriously.